Hello everyone and a very good evening. So before I start this session, first let me know if I'm visible and audible to you or not. Yes, good evening Yashat Kesarwani, good evening Kanika Thakur, good evening Disha. Yes, we have Keshri Bagela. Fenil is here. I'm doing good, Fenil. Thanks for asking. Yes, good evening Maitri. Hi Aditi. Yes. Keshvi is saying perfectly audible and visible and lots of thumbs up I can see. Yeah. Alright. Sachin Jaiswal is here. Hi Kanika Thakur, Pankaj Chauhan, Animesh Gupta. Yes. We have D. Deepak, D. Pratibha. Perfect and okay, ma'am. Mohammed Shamil PS. Yes, Fenil, I did check the homework answers that you have posted and I could see that only few of the students have answered this time. Yes. Excited, Charvi? Yeah. Good evening, Nidhi Agarwal. Yes. Hello, Gursifat Singh. Hi, Arush. Surajpal. Lots of thumbs up I can see. Hi, Kana Yadav. Alright, so there is no glitch at all, so we can start. My name is Khushbu and welcome to yet another wonderful session. So you know what we are going to study today, right? So what are we going to learn today? You must have seen the title of the video by now, right? So today we are going to have a one short session on circles. So everything that you have in this chapter, we will be covering all the concepts along with a few questions as well. Yes. Yes, Anushri, eagerly waiting for the session. Alright, so let's not waste any more time here. Let's get started. So let's first take a look at the different parts that make up a circle, right? So what we can see here is that one of the main parts of the circle that defines its center is basically, it's a fixed point which is equidistant from the boundary. This is basically the center of the circle. You can see that it is equidistant from all the points which are lying on the boundary. And then comes the radius, which is basically the distance of the center to any point lying on the boundary of the circle. So this is the radius over here. We all are very well aware of it, right? And then we have the circumference. So it's basically the entire length of the boundary of the circle that you can see here highlighted in pink. Yes. Yes. Yogi Shah, you have a doubt? Yes, definitely you can write your doubt over here. You can ask. Neon X Anshu. A difficult chapter. I could see that some students are saying it's easy, some are saying it's difficult. See, it's not difficult. In fact, I feel that none of the chapters in grade 10th are difficult. They all are easy if you understand the concepts well. Yes. Yes, Anshu, simple chapter. Yeah. Alright, so this is what that's called the circumference of the circle, the complete length of the boundary. And a part of the boundary of the circle, what do we call that? It's basically the arc of the circle. Like this is just a part of the boundary of the circle, right? The part which is highlighted in pink. Puneet, please refresh the screen once. Yes. Alright. Now, I am sure that all of you must have heard about the diameter. So, it's basically the line segment joining 2 points on the circle and passing through the center. You can see that it is joining two points which are lying on the opposite sides of this boundary, right? But it has to pass through the center. That's what we call a diameter. And we all know that diameter is twice the radius. Yes? Alright. Okay, now this brings us to chords. So what is a chord actually? You can see these chords drawn over here. These are the line segment joining any 2 points of the circle. You can see that it is joining these 2 points on the circle, right? And it is joining these 2 points on the circle as well. Now what if it joins the points, the opposite points on the circle also that passes through the center, right? So this line you can see over here, this is actually dividing this circle into exactly 2 equal halves, right? So half of a circle is nothing but that's a semicircle over here, right? So since it is joining any 2 opposite points lying on the boundary of the circle and it is passing through the center also, so that means it is a diameter, right? And it is a chord also. So I can say that diameter will be basically the longest chord of the circle. So it is one point that you need to remember. Yes, that's circumference. Yes. Circumference is basically perimeter only, the length of the boundary. But in case of circle, in case of the curvy figures, we use the term circumference. Yes, correct, Yeshat Kesarwani. Yes, Fennel. That's okay, Papiya. All right. Now let's move ahead, and now we will learn that what will happen if I divide this circle randomly in two parts, right? So what we can see here is that this is basically a chord. It is dividing the circle randomly in two parts. Yes. So what we see here is that the region shaded over here, right, in green, this is the region between the chord and this arc, and we call it a segment. Now since we can see that this is the minor arc of the circle, so the region between the chord and the minor arc, we call that as minor segment. Now you can see this region highlighted in pink. This is the region between the chord and between the major arc, right? So we call it a major segment. Yes. Confusion between sector and segment. Yes. Kanna Yadav, please refresh the screen once. Okay, mostly terminologies in the previous class. Are you talking about the segment and sector? Yes. See, if you talk about the segment, it is the region between the chord and the arc. You can see that this is the chord, right? And this is the arc. That's called the segment, right? I'm sure that all of you know what minor and major segment is now. Yes? Okay. Now what if, let's divide the circle differently now. Doesn't it look different from the previous one? Yes? From the segment that we just learned. You can see that the region is different. It is looking different. Look at the shaded part over here, right? So what we see here is that the region between the arc and the two radii, that's called the sector. Whereas segment was the region between the chord and the arc. It is between the radii and the arc, right? Between the two radii and the arc. That's called the sector. And here I can see that this is the minor arc, right? So region between the minor arc and the two radii, that's called the minor sector. Yes. And here this region is highlighted in pink. You can see that it is between the two radii and it is the major arc. We call it the major segment. Yes. This Shab heard crystal clear? Yes. I hope now you're not confused between the sectors and segments, right? All of you have understood what is the difference between them. Anshu, yes ma'am. Army OT 7 World, yes ma'am. Okay. Ashika Tripathi, yes ma'am. Crystal clear. Right. Charvi, one vertex. Yes, definitely, because Charvi, we are talking about the radius, right? Radius is always drawn from the center. Yes. So one vertex will always be, definitely it will be, one corner would be the center. All right. Maria. Repeat again. H22R dynamic, one time segment. See, when I talk about the sector, it is the region between the two radii. You can see this region is looking different from the previous one. And the arc, that's your what? That's called the sector. Yes. And this is the minor sector, that's the major one, because we are using the major arc over here. When you talk about the segment, this is the center and this is the chord, right? So this is your arc. Let me change the color. This, you can see this is the arc highlighted in green and this is your chord. So this region over here between the chord and the arc, that's called the segment. Since it is the minor arc, we call it the minor segment. And if you see this color in red, it is between the chord and the major arc, we call it the major segment. Yes. Question solving session. Yes. I'll tell you that, but today also we'll be solving a few questions, whatever concept we are learning. All right, Kanika Thakur, all clear? H22R dynamic, clear ma'am. Great. So now we know the difference between the sector and the segment. Now let's take a look at how to refer to lines that are associated with circles, right? So you can see we have a circle over here with this center. So if a line touches the circle at exactly one point, we actually call it a tangent, right? You can see this line over here. It is touching this boundary of the circle at exactly one point. That's called the tangent. But what if a line is intersecting the circle at 2 points? Then we call it a secant. So this is the secant. Now, now we know the difference between what a tangent is and what is a secant, right? Yes, Bhagyavardhan, absolutely. Siya Midha, yes, that's a tangent. Yes, Deepak, and that's the beauty of this chapter. There are only 2 theorems here. Yes. This is not confusing, Riya. That's very simple. Yes, today also I'll give you homework. Alright. Alright, so I think now you're ready to go ahead and try out a question, right? Because all these topics are clear in your mind. Okay. Let's take a look at this question, and now I want every one of you to answer this in the comment section. So how many tangents can pass through a given point on the circle? 4 options you have: 0, 1, 2 and infinite. Very simple question. Yes, we just learned about it. Hi Sukhjot, it's okay. Whatever you have missed, you can watch the recorded session later on. I can see a lot of answers, but some are saying it's 0, some are saying infinite, some are saying 1. Mixed answers are there. Yes. Absolutely, Night Rider. I'll be covering all the concepts. In fact, we'll be solving a few questions as well so that we get a better understanding. And separately, we are going to have a practice session also on this particular chapter, which is tomorrow. So don't worry about it. We'll be covering whatever course you have, that will be covered thoroughly. Some are saying D, some are saying 1. Yes. Okay. So let's see what the correct answer is. So to understand that, let's take a look at this. Suppose we have a point which is inside the circle. This point P over here, right? So this point is inside the circle. You can see that any line that passes through this point, it is intersecting the circle at 2 points. Right? So no tangent can be drawn to a circle which passes through a point that lies inside it, because we know that tangents touches the circle at exactly 1 point, right? Yes, Disha, but since there is only 1 point of contact, Night Rider, Byjus is the best. Thank you. Yes, Yasharth Kesavani. Inside, no, it is not possible. Yes. Alright, now let's take a look at another case when the point is lying on the circumference of the circle. That means the boundary of the circle, right? Now we can see that there is only 1 tangent that passes through it, right? So that means the answer to that question should be 1. Only 1 tangent can pass through it. Yes. Yes. Alright. Let's take a look at another case. What if the point lies outside the circle? So we have this point P over here which is lying outside. It is intersecting the circle at these 2 points T1 and T2. So these PT1 and PT2 are nothing but these are the 2 tangents, accurately 2 tangents to this circle. Yes. Correct, Disha. Yes. Rachel Ishwarya, learning is best with Byjus. Thank you. Sima Singh, 2 cannot be possible. No, there is only 1 tangent that can pass through it. For this case, yes, for this case we have 2 tangents, right? If it is outside, right, Bhagyavardhan, we have 2 tangents. Yes, Disha, PT1 and PT2 in that case would be equal. We have a theorem on this as well, right? Inside the circle, right, D Deepak, 0 tangents. Yes, correct. So all of you have understood this, right? Alright, now let's move ahead. So here we have an observational question for you. Now let's see who all will answer me. Okay? Alright. So you can see that there is one girl which is actually looking at 3 boys who are standing at 3 different positions from her for help. So could you tell me whom should she call among the 3 boys so that she could reach them? She could reach him at the earliest. Yes, correct. B is the right answer for the previous question. Correct. Quickly, I'm waiting for the answer. So who is the closest to this girl? Actually. Dilip Gupta, B, Jiva Dirshani, B, Disha Karukar, B is the closest. Niloji Beckham, B, Kanika, Swapna, everybody is saying B. Why B? Because we see here that this is the point, right, where girl is standing. If she asks for the help from this boy, you can see that it is a little longer, right, distance a little bigger. Similarly with this boy as well. But this distance over here, this looks shorter, right, because this is the perpendicular distance, right, and you can see that at this line, and this line, both these lines over here, they are intersecting at this point. That's the point of contact. Yes. Correct. B is the closest. Now, we have already observed the scenario, but this time we will observe the scenario when the girl is standing inside the circle. Now you tell me, are we going to get the similar answer that we got earlier, or the answer will change this time? Yes. Yes, I know, Shobha, you also answer it, right. Sukhjot is saying again B. Sachin is saying perpendicularly less than the hypotenuse. Okay. Sakina, perpendicular distance. Vaibhavi Sahu, B. Sia Midha, B. Right. Rushali Deshmukh, B. Disha Bhatt, same, B is the closest. Bhagyavardhan, similar answer. Abhay Kumar Rao, B. Rishu Pandey, similar. Okay. Shobha Kanvi, similar. Bhavika, Shiva Darshini. So everybody is saying that answer is going to be same. And the reason for that is, again, you see that this is the center of the circle where the girl is standing, right? And this line over here, it is touching the circle at exactly this point. Yes. And this is the radius, this much part. Distance between the center to this point which is lying on the circumference of the circle. But why is standing here? This point is outside. So definitely it is bigger than this radius, right? Here also, this is the radius, but the C is outside. So this is bigger than the radius. But we see here is that this is actually the radius of the circle. It is touching this line at this point of contact. And perpendicular distance is the shortest, right? So what we observe from here is that, so this is the line, this is the tangent, right? Which is actually passing to the circle. It is exactly touching the circle at one point. So the distance between this radius and tangent, right? This is the radius. This between the center and the tangent, this is the radius. At the point of contact, this is perpendicular. Yes, correct. So now we have a theorem in NCERT which is based on this only. Let's take a look at that. So it states that the tangent at any point of a circle is perpendicular to the radius to the point of contact. So what we see here is that we have a circle with a center O, right? And we can see that this line is touching the circle, the circumference of the circle at exactly one point. That's the tangent, right? This is the point of contact over here, this P. This OP is the radius, right? So now we see here is that amongst OA and OP, you would say that OA is anyways bigger than OP, right? When it is on this side. So why is it bigger? Because this much part over here, let's suppose this is point B, OB is the radius, OP is the radius. So definitely OB and OP, they both are equal, right? And OA is nothing that's equals to OB plus BA, right? So I can say here that this OA is actually equals to OP plus BA, right? So anyways, OA is equals to the sum of these two. It will anyways be bigger than OA, right? Okay, now if I move this to the other side of this line, again I will say the same thing. Again, this OA is bigger than this OP, right? So it will always be greater than this OP until it coincides with OP, right? Until P and A coincide with each other, right? So when they are coinciding with each other, what we see here is that is OP, or you can say OA, this is the shortest distance. And we know that perpendicular distance is the shortest when you talk about, when we saw here that A was here. So perpendicular is always shorter than the hypotenuse, right? And this tangent over here, both radius and tangent are meeting at this point of contact. And we observed in the previous slide that this point of contact is nothing but here, this is actually perpendicular, right? So we can say that tangent and radius are always perpendicular to each other at the point of contact. So tangent and radius are going to be perpendicular at the point of contact. This is what this theorem is about. Yes? The comments are not visible. Alright. Now let's move ahead. Let's take a look at the another theorem. That's theorem 2. I'm still not able to see the comments. So here in this theorem 2, it says that length of tangents drawn from an external point to a circle are equal, right? So what we can see here is that we have a circle over here with center O, and this is the external point P, right? And if you remember, just a couple of minutes before I told you, then when we have a point lying outside the circle, right? And when we draw the tangents from here to the circle, we have exactly two tangents which are equal in length. Now we are going to see the proof of it. So here PQ and PR are going to be equal. This is what this theorem says. Now let's see the proof. The comments are still not visible. All right. So here, what we will do here is that we will join this OQ and we join this OR as well, right? And we'll join this OP also. So once all of them are joined, and we know, we learned in the previous theorem that radius and tangent are perpendicular at the point of contact. So here this would be 90 degree and this will also be 90 degree, right? Because this OQ is radius and this is the tangent. This OR is the radius and this is the tangent. At the point of contact, we have a 90 degree angle. Still comments are not visible. Okay. So here what we see is that, so to prove this, right, what we are proving here is that this PQ and PR are equal, right? So to prove this, let's consider these two triangles over here, right? This triangle and this triangle. So what I can see here is that this OQ and OR are going to be equal, right? Why are they going to be equal? Because they are the radii of circle, right? They are the radii of the same circle. Okay, and this OP over here, this is going to be the common side amongst both of them, right? That's common over here. And this angle over here, these are 90-degree angles. That's what I just told you. Let's suppose this is angle number 1, this is 2. So angle 1 and angle 2 are going to be equal. That's each 90 degree. Why are they 90 degree? Because radius and tangent are perpendicular to each other at the point of contact. So these triangles are going to be congruent by RHS congruency rule. Right? So when triangles are congruent, their corresponding paths are going to be equal. So I can say that this PQ and PR are going to be equal in that case by CP, CD. This is what the proof of the theorem says, and that's what we were supposed to prove here. So these are the theorems that you have in this chapter. Now let's discuss the questions based on them. Still comments are not visible. Okay, so in the given figure, P and PB are two tangents drawn from an external point P to a circle with center C and radius is 4 centimeter over here. If P and PB, they both are equal, then find the length of each tangent, right? Figure is given over here. So what information do we have? This P and PB, because from an external point P, the tangents are drawn, right? So this PA is 4 centimeter. This PB is also 4 centimeter, right? The length of tangents it's given, it is equal. Radius is 4 centimeter. So C is the center. Let's join this C with A, right? This is the radius. This is 4 centimeter. So I'll join this CB also, right? This is also the radius. That will also be 4 centimeters since radius of a circle is going to be same, right? Now what we need here is that we need the length of each tangent over here, right? I'm sorry, this is not given in the question. I wrote it by mistake that P and PB are not 4. They are given that they are equal. Okay. So to find out the length of each tangent, one thing we know here is that radius and tangent are perpendicular at the point of contact. This is what we learned just a couple of minutes before in theorem number 1, right? So this angle would be 90 degree, this would be 90 degree. I can say that CA is perpendicular to AP and CB will also be perpendicular to BP, right? So this AC and BC both are going to be equals to 4. That's the radii of the circle. Correct? That is given in the question. Now AP and PB, they both are tangents drawn from the same external point P. They will also be equal because length of tangents drawn from an external point to a circle are equal in length. This is what we learned in theorem number 2. So since they are equal, you see that this angle is 90, this is 90, this is 90. So it's a four-sided figure, it's a quadrilateral. Sum of all angles is 360, so this will also be 90 degree. Now these two adjacent lengths are equal, all corner angles are 90 degree. I can call it a square. So I can say that BPAC will be a square. If it is a square, all the sides are equal. So AB, PB, BC, CA, they all are 4 centimeter. So this is what we were supposed to find here, length of each tangent. So this is 4 centimeter, this is 4 centimeter. Interesting question, yes? Still, I can't see the comments here. Okay, let's take a look at the next question. In the given figure, there are two concentric circles with center O. PRT and PQS are tangents to the inner circle from a point P lying on the outer circle. If PR is 5 centimeter, find the length of PS. Yes? So we have two concentric circles over here. What concentric circles mean? That they have a common center, right? So this is one circle, this is another one, they have a common center O. You can see that PRT and PQS are tangents to the inner circle from point P lying on the outer circle. P is lying on the outer circle and from here we have drawn tangents, right? This PRT and PQS. This is PRT, this is PQS, right? From here we have drawn tangents to the inner one. So PR is 5 centimeter. This is 5. We have to find out the length of this entire PS over here. Right? Now we know one thing, that this PR and this PQ, they are going to be equal. Why PQ and PR are equal? Because they are drawn from the same external point, right? For this inner circle, this is the external point. So length of tangents drawn from an external point to a circle are equal in length. They would be equal. So if this is 5 centimeter, this PQ will also be 5 centimeter. We learned one more thing here, that this is the center. And for this inner circle, this PS is nothing but that's the tangent, right? And radius and tangent are perpendicular at the point of contact, right? So since this is 90 degree and a perpendicular drawn from the center of a circle to the chord bisects the chord. Now, why am I calling this a chord? Because PS is a tangent for the inner circle, but for the outer circle, you see it is a chord. Yes. So, perpendicular bisects the chord, right, which is drawn from the center. So, I can say that PS is equal to twice PQ. Since OQ is perpendicular to PS, so PS is twice of 5 centimeter. I can say that's equals to 10 centimeter. I think there is some technical issue. Comments are still not visible to me. Okay, so PS, we have got its length. That's going to be 10 centimeter in this case. Yes. Right. Yes, Gamer King, now I can see the comments. Yes. I hope that you have understood the theorems that I explained to you. Sorry, I could not read the comments I think from Theorem 1 when I was discussing. I hope both the theorems are clear to everyone. Yes, Keshu Bagela, if you understand the theorems, chapter would be very simple for you. See, for any chapter, if you understand the concepts well, so you know how to apply them in any kind of question, right? So it becomes really simple for you then. Yes, Puneet Kaur, clear? Ram Gaikwad, yes ma'am. Tariq Bashir, which one? This question are you talking about? Muhammad Shamil PS, yes. Legendary Rider, yes. Yes. Disha, crystal clear, okay. Saif Pasha, yes, 10. Okay. Yasharth, yes ma'am, understood all theorems. Vartika, yes ma'am. Vaibhav Thakur, Sachin Jaiswal, Bhagyavardhan, Sia Midha, yeah. Greshal Ishwarya, yes. Okay, great. So we have understood the theorems as well as this question, right? Great. Alright, let's take a look at the next question. In the given figure, O is the center of the circle, right? This is the center. PQ is a chord. This is the chord. Okay. And this PT is the tangent at P. This is the tangent, right? This is the tangent, and we can extend this line till here. This is tangent. Yes. Ananya Kukreja, which question are you talking about? The previous one? Yes. Okay, let's take a look at the previous question one more time for the students who haven't understood this, because I was not able to read the comments, right? So, all right, okay. So here we are talking about two concentric circles, right? Concentric circles means they have a common center, right? So these are the concentric circles here. They have a common center, that is O. Now PRT and PQS are the tangents to this inner circle. Let's take a look at this figure. Yes. Common center, you can see the tangents are drawn to the inner circle. Look at the inner one. It is touching the inner one, right? Okay. PR, this much part only this much part. This is 5 centimeter. We need the length of this entire PS. First thing that we learn from here is that this PR is 5 centimeter. So this PQ over here, this will also be 5. Why? The length of tangents drawn from an external point, this is the external point to a circle, are equal in length. So PQ will also be 5 centimeter. We learned one thing, that radius and tangent are perpendicular at the point of contact. OQ is what? That's the radius. PS is what? That's the tangent for the inner circle. So this will be 90 degree, right? So PS is tangent for the inner one, but if you see, it is a chord for the bigger circle, for the outer circle, right? So we know that this is 90. So perpendicular drawn from the center of a circle to the chord bisects the chord, right? So I can say PS would be twice of PQ since it is perpendicular. So 2 times is 5. We can say it is 10 centimeter. I hope your doubt is clear now, Ananya. Yes? All right. OQ bisector of PS? Yes. Yes. And the reason is perpendicular drawn from the center of a circle to the chord bisects the chord. Since it's a subjective paper, you will have to mention the reason in the bracket for that. Correct, Disha? Yes. I've answered to your question. Understood. Great. So let's take a look at this question. I think a few of the students have already answered this. Okay. So we have a circle over here with center O, and PQ over here is nothing but that's the chord for this circle, right? PT is the tangent here. This is a tangent, or you can say line is extended over here, entirely tangent hai. POQ. POQ over here is 70 degree. Let's mark this angle as 70 degrees. We have to calculate TPQ. This angle I need to calculate. right? Now I know one thing, this angle QPO and PQO, QPO, this one, this angle, and PQO, this one, they are going to be equal. Why are they equal? Because you see that both of these, this and this, these are what? These are the radius of the same circle. So in a triangle, when two sides are equal, their opposite angles are also equal, right? So these angles are going to be equal. Now I'll apply angle sum property in this triangle POQ. Sum will be equals to 180 degrees. Put the values. What do you get? You get QPO plus QPO and QOP, that's equals to 110 degree. Since they both are equal, I can write them as twice of QPO equals to 110 degrees. So QPO would be 55 degrees. Okay. So this angle over here is 55. Now we learned one thing, that radius and tangent are perpendicular at the point of contact, right? So this is 90 degrees. This angle is also 90, right? From linear pair also you can say this is 90. I have this value. This is 55 degrees, right? So just put it here. You get this value as 35 degrees. That's the answer, right? 35 degrees is the answer. Yep. 55. Yes, 55 is angle QPO. Correct. Some are saying 70 degree. Epic Gaming, 70 is already given in the question. That's angle POQ. Yes. 45 degree, no. Anita, how 67 degree you are getting? How come you are getting 45 degrees? Yes, D Deepak, 35, not 45. I think you might have made some calculation mistake because this is a very simple question. Yes? Yes, Fenil, सबका गलत हो गया. सबने सेम मिस्टेक करी है. How is it possible, right? ऐसे कैसे हो सकता है? Yes. I hope Keshvi understood the mistake. Yes, it's 35. Right, 35 degree. Legendary writer, I'm explaining one more time. See, this is the figure that is given, right? We need this angle, okay? So we know that this is 90 degrees. So this complete angle from here, this will also be 90 degree. If I get the value of this much part that I'm highlighting here, on subtracting from 90, I'll get the rest of the part, right? Now this is the radius, this is the radius. So in a triangle, when two sides are equal, their opposite angles get equal. Let me show you here. These two sides are equal because they are radius. This is 70 degree. So these two angles will also get equal, right? Using the angle sum property, I can get this value which is coming as 55. They both are 55, right? Now this angle over here, complete angle over here, this is 90. So from 90, if I subtract 55, I'll get the rest of the part that's going to be 35 degree. Yes, D Deepak, comments copy kiya hai shayad sabne, right? Vaibhav Thakur, correct, 35 degrees, right? Saif Pasha, understood, right? Okay. So simple question hai, right? Kuch nahi karna hai. You are using the first property. First of all, ki if two sides in a triangle are equal, their opposite angles would be equal. Mention this property first of all. Then using the angle sum property, you will get one angle. And then you know that it is 90. Their sum is 90. Subtract karke you get 35. Understood the mistake, Disha, right? Okay. All right. Crystal clear. Great. Let's take a look at the next question. Please don't copy answers chat mein se ki what other person has written, you would write the same answer. Try it yourself. Only then you're going to learn it. Fenil, ma'am ek dusre se saath chat karke. Sorry, I could not read the entire comment. All right. Yes, nakal mein bhi akal lagti hai, right? Okay, let's take a look at this question. So here we have got two tangents, right? P and PB. This is the external point. External point se we have drawn these two tangents over here, P and PB. But look carefully at this figure. This line segment is drawn to the outer circle, right? This one is drawn to the inner circle. Yes? Yes, सबकी mentality same हो गई है, 45 degree आया. Unity is strength. हाँ, यहाँ पे completely applicable है ये. Saif Pasha, ma'am, you are my best maths teacher. Thank you. Okay, now it is given that radii for the bigger circle is 8 centimeter and from the smaller one it is 5 centimeter, right? This is the radius for the bigger one, this OA, correct? Because center se it is joining the point which is lying on the boundary of the circle. So this is 8 centimeter. And this OB over here, you can see from center it is joining this part. So that's going to be 5 centimeter, right? Okay. We have AP length. This is 15 centimeter. You need the length of BP, right? So important thing over here is this is drawn till this point, which is the basically the part of the, this is a point on the outer circle, and this is drawn on this point, which is basically a point on the inner circle, right? Okay, now I'll do one thing. I'll join this OP first. Okay. Now we know that radius and tangent, they're always perpendicular at the point of contact. This angle should be 90 degree, correct? Okay, I'll change the color. I hope this is visible now. I'm marking one more time. This AP is 15 centimeters. This OA over here, that's 8 centimeters. OB over here is 5 centimeters. See, when you come across such questions now, I would suggest you please draw the figure along with me. Akash, I hope it is visible now, yes? Yes. Okay. Alright, so 8 centimeter and 5 centimeter, right? This is given. So I'll join OP first. Now we know that radius, this is the radius and this is the tangent. Radius and tangent are always perpendicular at the point of contact. This is what we learnt in Theorem 1, correct? Okay, so we will apply Pythagoras in this triangle OAP. So this is 90 degree angle. The side which is opposite to this 90 degree angle, that would be what? That's the hypotenuse. That's the longest side, right? So OP square would be equal to OA square plus AP square. All you have to do is just substitute the values here. What do you get? You have OP square equal to 8 square plus 15 square, right? We have OP square equal to 64 plus 225. So OP square is 289. OP would be equal to 17 centimeter. So we have the length of OP. Yes. I have OP here, but I need the length of BP. So this is 17 centimeter. Again, this OB, right? This is the radius for the smaller one. And this BP is the tangent to the smaller circle. Again, radius and tangent would be perpendicular. So this is also a 90 degrees angle. Correct? So I'll apply Pythagoras in this triangle now. So OP square equal to OB square plus BP square. That's 17 square equal to 5 square plus BP square. You get 289 equal to 25 plus BP square. So BP is equal to square root of 264. Now we need to simplify this further, right? I tell you one thing. One way to solve this is the traditional long division method that we do to find out the square root, right? Another one is that you can apply a trick over here to find out the square root. If you want to, and because sometimes you come across questions in Olympiads or NTSC also, like, so there you can, instead of using that traditional long division method, you can use this trick. So this will help you later on also when you go for the competitive exams. Okay, let's take a look at this. We have root 264, right? Now think of the numbers, right? Think of the numbers which have the closest to root 2, closest to 264, which are perfect squares, right? So we know it's 256 and we know it's 289, correct? 256 closer and 289 closer है 264 से, which are perfect squares, right? So square root of 256 is nothing but that's 16, and for 289 it's 17. We know one thing, 264 is lying between 256 and 289. It is neither 16, it is not 17, it is somewhere between this, right? Definitely it is 16 point something. I don't know what will come after 16 here. Yes? Alright, what will come after 16, that we need to find out here. So to find this out, what you can do here is subtract this 256 from 289, right? This 256, when you subtract from 289, what do you get? You get 33. Now you will subtract this 256 from 264. What do you get? You get 8, right? So 8 by 33. We know it is 16. That's the whole number part. Then the decimal. But what is after that? 8 by 33. We know one thing. 8 by 32 is basically 1 by 4. That's nothing but that's 0.25. And 33 is just one number bigger than 32. So when denominator is a little bigger, so definitely the answer would become lesser at the end. So rather than 25, you can say it's 0.242424, something like this you would get. So to get the approximate value, it's going to be 16.25. Yes, 16.25, that's the approximate value for this. I can see some are saying 2 root 66. See, proper final answer, you cannot leave that in roots. You have to give that in decimals. Yes, Bhagyavardhan, 16.242424 something, that's the approximate value. Yes. So when it comes to finding out the approximate values, you can use such tricks if you want to. Correct. 16.25, yes. Anushri Solanki. BP, the hypotenuse. Why? Because this is the radius for the smaller circle. This is the tangent to the smaller circle. This is going to be 90 degree, right? So how can this be hypotenuse? Because 90-degree angle is found between the perpendicular and the base, right? And the hypotenuse would be the side which is opposite to the 90-degree angle. Correct? Right, Ananya? Because you see, it is drawn on the between the perpendicular and base. How can you call it a hypotenuse? Yes, Bebhav Thakur, that's the approximate value. Saf 16.22, you can't say it would be 16.2425 something, yes. Yes. Yes, Suraj Pal. The trick, yes, I'm repeating one more time. Think of the closest perfect square number, right? That is 256 and 289. 256, we all know the square root still 20 or 25, right? So, alright, so we can, 256 square root is 16, for 289 it is 17. So 16 तो definitely है, because जो इसका square root होगा, that will lie between 16 and 17. It is neither 16 nor 17, somewhere between this. It would be 16 point something. Whole number part is fixed, 16 hai. But what about the number after the decimal? So what I'll do here is, what you have to do is, this is the smallest among the three numbers. You subtract this number from both of them, one by one. 289 minus 256, you get 33. 264 minus 256, you get 8. Divide them. 8 by 33 is going to be, so rather doing division over here, think of the number, whole number जैसे कोई. Like, I mean, ऐसा कोई number which you can cancel out 8 से directly. Like we have 32. So we get 1 by 4, which is 0.25. Now this is 33. If it is 0.25, that's going to be 0.24 something, right? So answer is going to be 16.242424 something, but approximate value you can say 16.25. Approximation may, when you have to give the answers, you can use this trick. Yes. Yes. Understood, Saif? Correct, absolutely, right. Alright, Disha, thank you. Now let's take a look at the next question. So in this figure, PQ and PR are tangents to this circle with center A over here, right? And QPA over here, that's going to be 27 degrees, right? We have to find out the value of this QAR. So PQ and PR are two tangents. If you talk about these two triangles over here, this triangle and this triangle, we know one thing, that this QPA, first of all, these two triangles are going to be congruent, right? Why are they congruent? Think about it. These are the two tangents to the circle. So length of tangents drawn from an external point to a circle are going to be equal, right? That's our theorem number 2. Thank you. You like the trick, yes? Great. So you can use these tricks whether in your exam, because that long division method, I would say that's a little time consuming, right? Yes. Alright, so PQ and PR are going to be equal over here. Yes, because according to theorem number 2, AQ and AR, what is this? This is nothing but these are the radii for the same circle, and AP and APA, they both are common over here. So I can say the triangles are going to be congruent by SSS congruency rule. Now since triangles are congruent, I can say that this angle QPA and this angle RPA, right? These two angles are going to be equal. This one which I am highlighting here. Yes? Okay. So this is 27, so angle RPA will also going to be, that is also going to be 27 degrees. Now this angle QPR, this is QPA plus RPA, right? You add both of them up and you get the complete value. That's going to be 54 degrees, 27 degrees plus 27 degrees. Now when you talk about this angle over here, so this is nothing but that's a quadrilateral. It's a four-sided figure, right? This is 90 degree, this is 90 degree, these angles over here. And this is 27. So this complete angle is 54 degrees. This is 90, this is 90. Now we need this value. Complete sum is going to be 360 degrees. Substitute all the values. And you get 360 degree minus 234 degrees, which is going to be 126 degrees. Again, mixed answers I can see. Yes, Yashat, 126 degrees, right? Whole P, whole angle A. Correct. Yes. Yes, that's correct, Deepak, right. That also you can use. 126, right, Bhagyavardhan? Beyond the scene studios, 126 degrees, right? Somebody said 63 degrees. See, we need this complete angle. I think you're finding out the value from one triangle only. We are using the quadrilateral over here. Yes. Correct. Alright, so that's the right answer for this question. Now we all have understood, right? So this was the last question of today's session. Now it's time for the homework question. So let's take a look at that. All right. So we have a question here that you can try out later on after this session, and you can answer in the comment section below. It states that in the given figure, the sides AB, BC and CA of a triangle ABC touch a circle at P, Q and R respectively. If PA is 4 cm, BP is 3 cm and AC is 11 cm, find the length of BC in centimeters. So I hope that all of you know how to solve this, yeah? We'll be using the second theorem because we are talking about the length of the tangents here. This PA over here is 4 cm, this BP is 3 cm, and this AC over here, this complete length, that's 11 cm, right? So we know that length of tangents drawn from an external point to a circle are equal in length. Using that theorem, you can find this out. Yes, Charvi Parker, yes. All right. Yes. Yes, I could see that some students have answered to the previous homework question, but not all of you. Okay, so I hope that all of you have noted down this question, yes? Or you have taken a screenshot. Quickly. Yes, Amatya, some students have already given the answer. All right, all right. Yes, Ananya, correct. Dishabhat, wonderful questions. Thank you. Yes. So all of you have noted down the question? Yeah? Okay, okay. All right, so this is not the end. We have got many more sessions for you from Monday to Friday to make you exam ready. Now let me give you a glimpse of the upcoming session. So next session is on February 4th, that is Friday. That means tomorrow, which is at 6 p.m. And tomorrow we are going to discuss some critical questions on circles. Trust me, all the concepts we have covered today, like whatever concepts you have in NCERT, they are done, right? Tomorrow I'll be covering some very good questions which are very important from exam point of view. Yes. Yes, Amartya Sakar, yes. Yes. Yes, Anushri Solanki, I just told you. Yes, tomorrow session it's at 6 p.m. and it's on some critical questions for circles, right? So we'll be covering some challenging questions, some very good questions from exam point of view tomorrow. All right. So please do not miss the session, and please do like, share and subscribe so that you get notified about the upcoming sessions. So I'll see you soon. Until then, be curious, keep learning. Thank you.